Good morning. Welcome back. I just want to say, I just sent out an announcement that on Monday, I have scheduled extra hour of office hours just because I had nothing scheduled before the test. So if you don't want to make an appointment or email from 3 to 4 p.m. on Monday, I have scheduled office hours. You can still make an appointment. You can still email me, but there is a 1 hour block where I will be in Zoom. So Monday from 3 to 4, I'll be available. I can't go over 4 because I have another appointment with the Writing Center right after, but before 3, I have time. And if you do need to see me after 6 when my Writing Center is done, I can probably make some time too. Okay. Um, so last time we talked about truth tables and all these different operators for ands, ors, if then, if and only if, not. And I've just put them up in the top right of this slide as a summary so you can take a look at them all. We talked about different ways that we can construct them and the different definitions. And that's one way is just remembering the definitions every time. But when you do these a lot, and sometimes just as a way to memorize them early, you just kind of memorize these as a string of numbers. So remembering the and table as a 1000, for example, just means that from top to bottom, if you write the truth table the same way every single time, and is always 1000, or is always 1110. If you're in computing science, sometimes you flip them around, or especially if you're in engineering, you flip them around. You do the zeros first and the ones after. But memorizing them is fine too. It's really up to you how you want to do truth tables. Um, but today we have two goals. One is building more complex truth tables for when we have more than just two statements. And then the other one is taking English sentences and translating them into logic and then building truth tables from those. So our first step is just building a more complex truth table. So that's what this slide is showing. And then you're going to have a chance to do it yourself. So instead of just showing the tree, I've also given you an English example just as a precursor to how we can translate English sentences into logic and then do everything. So here's the example we'll work with here as a demo. So if Prancer and Donner fly away, Cupid will be alone. And there's this hidden then here. In English, sometimes we omit the word then, but it's always hidden there. So if Prancer and Donner fly away, this is a condition. So this is an if word. So everything after the if is what's called the antecedent. Then, so everything after then is what's called the consequent. So this helps us figure out what's on which side of the arrow. So there's going to be an arrow somewhere in our formula here. So then Cupid will be alone. So everything after the arrow, Cupid will be alone. But we have to figure out how we're going to take these words in English and translate them into logic. So we're going to give each of these different letters. So P will be Prancer flies away. D will be Donner flies away, and C will be Cupid will be alone. I'm just picking these letters because these are the names of the reindeer. So P is Prancer, D is Donner, C is Cupid. This just makes it easier for me to remember. So we can just use these letters. So Cupid will be alone. That's our consequent. That comes after the arrow. And then Prancer flies away and Donner flies away. So that will be P and D. So Prancer flies away and Donner flies away. And that's our condition. So these occur before the arrow. So what we end up with is a translation like this. If P and D, then C. So if Prancer flies away and Donner flies away, then Cupid will be alone. Okay, so it's not a very complicated sentence, but it's still a sentence where we have to do some work to translate it. And as you can see, I've broken down the structure into its syntactic components. So we've taken the if-then statement and we've broken it up into two components here. So P and D, the arrow, and then the C. And then we've broken up the P and D into P and D. So why have we done this? Well, when we're building our truth tables, our operators only work on one or two things at once. If it's a not, it only negates one thing at a time. If it's an and or if and only if, it only works on two things at a time. So truth builds piece by piece. So the way that truth builds up in a truth table is the same way that it builds up syntactically. So if we know how to build our syntactic structure, we know how to build a truth table. So uh, on the right here is a chart. It's a truth table. So this is going to be how we're going to track all the possible situations, all the different combinations of truth, and how truth changes how we go up our truth tree. So we're going to know what happens to the truth of P, what happens to the truth of D, what happens to the truth of C. We're going to know what happens to the truth of P and D. And in order to know what happens to the truth of this entire sentence, P and D arrow C, we need to know what happens to the truth of its two kids here, its two daughters, in terms of syntactic terms, daughters, sisters, mothers. We'll talk about those terms later as well when we talk about the actual tree structures, if you need a review for those. Okay, so the first thing is setting up our truth tables. And I'm going to put a little extra line here to separate what we start with and what we have to figure out. So whenever we have a single variable like A, B, C, D, E, F, G, we can start by filling those in because we know what they are. And I always start with the rightmost one. So in this case, we have P, D, and C. So I'll start with C, and I just alternate ones and zeros. So 1, 0, 1, 0. And I'm doing this so that way, by the end of this little algorithm here, I'm going to get all different possible combinations of truth. And that way, all the truth tables I do will be consistent. Then as I move to the left, I'm just going to double up on the ones and zeros. So instead of doing 1, 0, 1, 0, I'm going to do 1, 1, 0, 0, 1, 1, 0, 0 until the entire thing is filled. So 1, 1, 0, 0, 1, 1, 0, 0. And as I keep moving left, I'm going to keep doubling up. So now it'll be 1, 1, 1, 1, 0, 0, 0, 0, and I'll keep going until I fill everything up. So 1, 1, 1, 1, 0, 0, 0, 0. Now, this will give us all different possible combinations of truth. Now, why I show this particular strategy is because no matter how many variables we have to work with, this strategy will work. So if there's 5 variables to work with, we're going to have 32 lines in our truth table, but this will still give us all possible combinations of truth. So you don't have to worry about thinking, do I have the case where all 3 are true? Do I have the case where P is true and then D and C are false? No, you don't have to think too much about that. If you just follow the algorithm, you'll have all possible combinations. So alternate 1, 0, then double up on ones and zeros, and then double up again. Okay, so now at this stage, we're just building up our truth piece by piece. So because I have P and D in our truth table, I'm now building up the component where we look at P and D together. And I just have to compare the truth value of P, the truth value of D, and look at the operator for and ask myself, well, what do I get based on what we talked about last class? So P and D, this one is true when P is true. Let me use the actual notation that I should be using. So when the value of P is true and the value of D is true. And I really shouldn't be using the word when here. I should be using the word if with 2 Fs. So in the first, so basically we're comparing these 2 columns, the P column and the D column. So in the first row, P is 1 and D is 1. Therefore, P and D will be true. Since both P and D are true, therefore P and D is true. Okay, second row, same thing. P is true, D is true, therefore P and D is true. Okay, third row. This is where things change because P is true, but D is now false. We have D is 0 in the third row. So now P and D is going to be false. Okay, in the fourth row, we see the exact same thing. So fourth row, I'm comparing right here. P is 1, D is 0. Well, they're both not true. Therefore, P and D is 0. Get rid of that box there. Okay, fifth row. Now P is false, but D is true. But they both have to be true for P and D to be true. So P and D will be false. And in the sixth row, it's the same thing. Finally, in row 7 and 8, they're both false. So those last rows are false as well. Okay, so that row wasn't too bad. That was just applying P and D. But now we got to go to our final row to see the truth of the entire sentence in all possible circumstances. So now we have to compare two things. So if we clean up this diagram a little bit on our tree, we have to compare the values of P and D, and we have to compare the value of C. So when we take a look at our truth table, to clean things up a little bit, we have to compare this column, the P and D column, and we have to compare the C column. So we might have to take a look at our reference here. So how this is going to work with P and D arrow C, this is going to be false if P and D, I'll just move my webcam out of the way for this one so I can write it down here in the corner. This is going to be false if P and D is true and C is false. So that's just the definition of the arrow. So if we take a look at the truth table in the top, so that's for alpha arrow beta, it's only false in the second case, when alpha is true and beta is false. So that's when the antecedent is true and the consequent is false. Thing on the left is true, thing on the right is false. But when we're taking a look at our truth table down here, we have to remember that P and D is actually on the right. So this is our antecedent and this is our consequent. So in our heads, we have to remember which is on the left side of the arrow and which is on the right side of the arrow, because on the table, they're backwards. So what I like to do sometimes is actually write it in the column. So for instance, in the first row, P and D is 1 and C is 1. So I have a 1 arrow 1 situation here. So I know that this column or this entry will be true. So this is if true, then true. So P and D arrow C is true. So this is my antecedent, this is my consequent. What about the second row? P and D is true, so that's my antecedent, but my consequent C is false. So here I have 1 arrow 0, so this entry will be false. So in the second situation, where Prancer flies away and Donner flies away, but Cupid is not alone, the sentence is false. So I just want to take a step back and take a look at the big picture here for a second, because we just did a truth table for this, but what does this all mean? Remember, we took an English sentence. If Prancer and Donner fly away, Cupid will be alone. And now we're asking about the truth of this sentence. This second situation says, what if Prancer does fly away, Donner does fly away, but Cupid is not alone? Is that original sentence true? And this says, no, that sentence is not true. If Prancer flies away and Donner flies away and Cupid is not alone, then the entire sentence is false. But the first row says, if Prancer flies away and Donner flies away and Cupid is alone, then the sentence is true. Okay, so we can keep continuing along with the truth table. So in row 3, P and D is false. So that's our antecedent. We have an arrow, and then C is true. So we have 0, arrow 1. And if we look at our truth table, this corresponds to line 3, where we have 0, arrow 1. And this comes out to be true. So it's going to be true in line 3. And if we take a look at all of the rest of these rows, all of the antecedents P and D are going to be false in these cases. And one of the things about the conditional is that if that antecedent, if that condition is false, uh, it's always going to come out to be true. That's one of the little quirks about the conditional. So we can say that in every other case, this sentence is going to be true. Because we can't test to see if the condition is false, we just say that it's true overall. So this is how we build a truth table for a more complex, well-formed formula. We take a look at its syntactic structure to figure out how to build the truth table, and then we just build truth up piece by piece. So are there any questions about the process or what the truth table means in the end?
Can you explain again why we have how we can determine that if the antecedent is false, the thing is gonna be true? Because you said something about you can't test something or
Oh, sorry, that's just my little way of explaining this. So the definition of the conditional is that it's false if the antecedent is true and the consequent is false. So if you say something is going to happen based on a condition and then it doesn't, it's false. It also says that if the antecedent is false, the conditional will always be true. So my way of explaining this is more so if you say that if something happens, then something else is going to happen, but you don't have a way of testing it because that condition never happens, then you don't want to say it's false. You just say it's true until you can prove that it's not going to happen.
okay, thank you.
Like, if it rains, I'll take an umbrella outside. Well, if it rains, you can never really check if you're going to take an umbrella outside. So you don't want to say that condition's false until you can actually see if it rains or not. Okay, so uh, you don't have an English sentence to correspond with this, but what I'd like you to do is I'd like you to try to build the truth table for this and um, see if you can come up with the final values for this complex, well-formed formula. And what I'll say about this, and I'll just set up the first two columns for you, because you only have, I'm going to need more space for this, um, because you only have two variables here, you're only going to need 4 rows. So you don't need to do 8 rows. But I'll give you about 5 minutes for this one because it will take a little bit longer the first time you do it. But if you have any questions at all during the process, again, feel free to ask questions or type in chat and I'll respond. If you don't need to do the syntactic tree, don't worry about it. That's just for you to get started to see which columns you need. If you're comfortable with setting up each of the columns, then just work on the truth table. But if you're unsure of which ones you need to do, like how to build each of the columns to go piece by piece, then definitely draw a syntactic tree first. Okay. So we start, so I have the syntactic tree on the left, and I wrote that earlier just in case that was beneficial. So we already have the entries for the P's and the Q's. So what we need to build these, and you have a choice if you want to do P and Q first or not Q, but we can do not Q first. So we need an entry for not Q. So we'll have to put that in here. So why not just do this first? So not Q is just going to take the values of Q and just flip them. So if Q is 1, then not Q will be 0. So when Q is 1, not Q is 0. And when Q is 0, not Q will be 1. So this is just a flipped value. Okay. We just did not Q and we have P. So let's just do not Q arrow P next. If you do P and Q next, it doesn't matter. So it doesn't matter what order your truth table is in, as long as all the pieces are there in the end. So let's do not Q arrow P next. Okay, so we're looking at this column and we're looking at this column. And because I have a conditional, I'm just going to write the little numbers in the bottom left so that way I can keep track of them. But I'll do them in one color just so I don't have to switch back and forth. So here I have in the first row, not Q is 0 and P is 1. So here I have 0 arrow 1, so the antecedent's false. So in this case, the conditional will be true. Conditionals are always true when the antecedent's false. In the second row, not Q is true and P is true. So there I have 1 arrow 1. So this is fine. The antecedent's true and the conditions or the consequence true. So this will be true as well. In the third row, antecedent is false. So 0 arrow 0. I mean, it doesn't matter what the consequent is in this case because the antecedent is false. This will be true. But in the final row, not Q is true. So the antecedent is true, but P is false. The consequent is false. So this is the case where the conditional is false overall, because I've said if the antecedent is true, well, the consequent is false. This should not be happening. If the antecedent is true, then the consequent should be true, because I'm saying there's a condition here. The condition has been met, so why hasn't the result happened? Okay, so we have our condition. So that side's done. Now we can't do our well-formed formula at the top yet because we still need that information from the left side. We need P and Q. So we need to do P and Q next in order to make any more progress. So let's do this one. Well, this is really nice because we already know the truth table for P and Q is set up just the same as always. So 1, 1, 1, 0, 0, 1, 0, 0. So it's going to be true in the first row since both P and Q are true. And then in every other row, these are going to be false because at least one of P or Q are false. So this is a very prototypical example of P and Q. So you don't have to put much thought into it there. Just kind of nice. Okay, so now we can finally tackle the big one at the top. I could write this all out and I have enough space, so I will. But sometimes I might want to be lazy, and you can be lazy too. It's okay. Sometimes I put little numbers above some of the columns in my truth tables, and I would just write 1 and 2. Or sorry, that wouldn't be 1 and 2. That would be 1 or 2, sort of as a way to abbreviate my writing. And that's okay with me if you want to do that to save yourself some time. But because I have space and for illustration, I'm going to write everything out. But as long as I know what you're doing, that's okay. Okay, so now I need to take a look at these two columns, P and Q, or not Q or, sorry, not Q arrow P. So this is an or, so just one of these two has to be true. Either not Q arrow P has to be true, or P and Q has to be true. And then we can put a 1 in there. So for the first row, uh, just one of those has to be true. And I see that P and Q is true. Okay, so uh, first row is true. Second row, P and Q is false, but not Q arrow P is true. Therefore, the or in this case is true. Third row, same thing. Not Q arrow P is true. Therefore, the whole thing with the or in between is true. Last row, though, P and Q is false. Not Q arrow P is false. Neither of them are true. Therefore, the or whole thing is going to be false. So that's how we build a truth table for a more complex Wolfram formula. Did anybody not come out with this in the end and not know why they've made an error or have any questions about what went on with this construction? Yeah, so it's usually pretty common at the beginning. And when you do your assignment or the practice exercise, the conditional with the truth tables, 0 arrow 0, putting it down as 0, it's a very common mistake. So just remembering, if you have 0 arrow anything being true, um, that's one of the very early misconceptions. So um, definitely double check the if truth table when you're doing your assignments and practice exercises at the beginning. Assignment 3 is released, so you should be able to do the truth table question at this point. Um, the truth tables I give you are actually very similar to the difficulty of this one. Truth tables are more so a work in like tedium, because the bigger the truth table gets, it's not any more difficult. It's just more work. So I'm not giving you giant truth tables. I'm just giving you truth tables with like, uh, you know, probably 6 columns overall in the end. So this is a 6 column truth table. They're about the same in the end for most of the ones I give you because they're not harder, they're just more work. So there's no point in giving you something that's a lot of work. Okay, so the next step is translating English into logic. And then we'll do more truth table practice with that once we can translate English sentences into logic. Because really, that's the important point in the end. And that's what we're going to be doing in the course when we do our tree structures. We're not translating it into logic, but we're using the notion of logic to help evaluate sentences. So here's some tips for doing this. And you don't need these tips in order to do it. Some of you could probably jump right into sentences and just try your best with all of the things that have been given so far, but here's some tips to start out with. The key thing when looking at English sentences is to identify connective words. So these are your conjunctions and disjunctions and conditionals. So words like and, or, if, then, however, although, when, moreover, uh, if and only if, unless, all of these words in English that you consider to be conjunctions. These are words that you should be identifying and you should be isolating from the rest of the sentence. If you want to underline them or box them, words like not as well, just so you're aware of where they are. Another thing too is that if you see words like if or only if or when or anything that signals some sort of conditional or antecedent consequent relation, rearranging sentences is often a good idea. So that way you know where the antecedent is. So you can rearrange it so that way you have an antecedent consequent left right translation. Because sometimes when you have a sentence like, um, I will go out if you leave, there is a temptation to put the I will go out as the condition. But that's not actually the case here. because the if is always going to occur before the antecedent, before the condition. So the you leave is really on the left side of the arrow. So if you leave, then I will go out. The second thing is when you define your statements for propositional logic, they should always be affirmative sentences. So not and these clitics or what's the English grammar term that's used in high school? Contractions. Contractions, that's the word. Um, these are connectives. So connectives are things that modify statements or propositions. So propositions should always be affirmative. So if you say, like, Steve doesn't like trips, the proposition should be Steve likes trips. So Steve likes trips should be S, and the sentence should be translated as not S. So Steve does not like trips. And third, translate piece by piece. And that's just something that sort of you intuitively do, but it's a good thing to just say explicitly. So, as an example, and here's what I've done piece by piece here. Here's the sentence. Corin robs a bank and gets rich when Charla buys the equipment or does not forget to hire a bodyguard for the job. So I'm giving you a really messy sentence to start with, because if I illustrate this with a simple sentence and then give you a harder thing after, what's the point of even giving you the tips? So here's a messy sentence. So what I've done first is I've identified a bunch of different connective words. So Corin robs a bank and gets rich when Charla buys the equipment or does not forget to hire a bodyguard for the job. So prepositions like for, that's a content word, so we'll keep it in. To is the same thing. We're just looking for words like and, when, or not. Okay, so the thing about the word when is a lot like the word if. So the antecedent of the sentence is occurring after the word when. So what I'm going to do to make this easier for me to translate is I'm going to rearrange the sentence so this when part occurs earlier. So that way when I translate this into logic, I don't have to worry like in my head what's coming before the arrow. I can just translate directly piece by piece in the sentence and just write the letters like on the page and everything will come out as nice as I can make it. So all I'm doing at this point is just rearranging the clauses in the sentence for my convenience. And I'm even like inserting the words if and then just to help me out. So when or if Charla buys the equipment or does not forget to hire a bodyguard for the job, then Corin robs a bank and gets rich. So this is the same sentence. I've just rearranged some things. Okay. Next, I am defining my keys. So I've sort of defined my keys backwards, but that's okay. But you'll notice they're all affirmative. So I have Corin robs a bank. So that's my R. And one thing about keys that I'll remind you is, first of all, let's not make this like 200-point font. So one key is just like a subject and predicate. That's it. So like a simple declarative sentence. So Corin robs a bank. I'm choosing R for robs a bank here. Gets rich. So this doesn't have an explicit subject here, but we know that this means Corin gets rich because we can paraphrase this. Corin robs a bank and Corin gets rich. So this is like another key here. Corin gets rich. We have another piece of information here. Charla buys the equipment. So I'm going to call this E for equipment. Now the last one does not forget to hire a bodyguard for the job. So this is Charla. Charla does not forget to hire a bodyguard for the job. I have to remember, not is a negation. So I'm not including this in my key. I'm just going to say Charla forgets to hire a bodyguard for the job. That's affirmative, that's positive, so that's my key. I'm not including that negation in my key. So there's four simple declarative sentences in this uh, compound complex sentence, which is compound sentence. So those are my keys. And now at this point, I'm just going to remove a lot of markers here, and I'm just going to translate piece by piece. So I have my keys. I know where my connectives are. So let's just go piece by piece. First, what I'm going to do is I'm just going to put my connectives where the connectives are. So or is here. I'm going to put a not here. I'm going to put the arrow here for then. I'm going to put the and here where the and is. I am going to put brackets around the ifs and the thens, just because I know that those conditions are separate. The antecedent is separate from the consequent. Okay, this isn't going to line up perfectly, so I'll have to do some rearranging of the letters after just to make things line up, but we can go piece by piece. So Charla buys the equipment. This is E, according to my keys, or does not forget to hire a bodyguard for the job. So Charla forgets to hire a bodyguard, that's F. So does not forget would be not F. Okay, so I've taken care of that. Then Corin robs a bank. So Corin robs a bank, I've said that's R. And then gets rich. Corin gets rich, we call that G. Okay, so now if we read everything from left to right, in terms of our translation directly on the sentence, we get E or not F, so I put down here, arrow, R and G. And then we have the brackets around the consequent and the brackets around the antecedent. So in the end, this was a well-behaved sentence that happened to translate piece by piece perfectly as we wanted. We just had to set it up in a way where we rearrange the antecedent to occur at the beginning and the consequent at the end. Otherwise, we would have had to do some mental work because we would have had E or not F after and R and G first in the original sentence, and there would have been some arrow over here. But this is how we translate a sentence. So this is not an easy task at the beginning. And here I've used words that we're familiar with, and, or, not, when. When is kind of a little bit different than if. But sometimes you run into different words like however, in addition to, unless. I'm trying to think of other words for if. Whenever. And you might have to think a little bit like, which connective is this? And you have to reason it out, or something like only if rather than if. And you have to ask yourself, is only if the same thing as if? And there is one question on the assignment like that, but I give you a little bit of a hint, like a question to prompt you and think, well, which way does this work? And there's a little bit of logic that I prompt you to think about that. So are there any questions about this process?
Isn't only if biconditional?
If and only if is the biconditional. Um, if is, so there's if, there's only if, those are conditionals, and then if and only if is the biconditional. So if I see, so if I see when it is a conditional. So I'm not understanding the sentence there. I'm not understanding the question there. Maybe I'm just parsing it poorly. If I see the word when, does that give a hint? Yeah, so when is a conditional. Um, so you can think of the word when. When is a condition, right? When you do something, something else happens. When you hear the word conditional in logic, condition is a major part of the word, and that like don't um, what am I trying to say here? In plain English, I'm trying to say the word condition, the part of the word condition, means condition. So don't try to think too philosophically or too scientifically about these terms. When you hear an English word and you think there's a condition coming from this word, it's a conditional. Well, unless it's the when that refers to time, like I know when you're available. Like that's not a conditional. But when you do this, something else happens, that's a condition. Okay. Um, so I don't know if we'll be able to go over the answers to these today, but I do want you to take 6 minutes to try these. And after the test on um, Tuesday, we'll talk about the solutions to these and we'll review these. We're basically finished with this lecture. So on Tuesday after the test, we'll talk about these ones. We'll briefly talk about some terms. Uh, so that'll take like 20 minutes or so. And then we'll just have a very light talking introduction to truth conditional meaning of sentences. So Tuesday will be a very, very, very light day in terms of content because you have a test. But I do want you to take, a few minutes to look at these and try these out and ask any questions. Um, so yeah, work on these for a little bit. Once you feel like you've gotten a good grasp on them, you're free to leave, or you're also free to ask any questions. Actually, hold on a second. We have 5 minutes left. There is test one on Tuesday. So, how about instead? I'm just thinking about time. So, how about instead, if you have any questions about test one on Tuesday, why don't we do that instead? We'll just leave this until Tuesday. Um, that's okay. We can leave this until Tuesday. So, are there any questions about the test that's coming up on Tuesday? I think that's a better use of the last 5 minutes. Will our assignments be marked before the tests? Your assignment 2 is already marked and the grade is already released. Assignment 3 is released. Assignment 3 is not due until after the test. Assignment 3 is on propositional logic. So assignment 3 is due a week after um, the test. So the test 1 covers assignments 1 and 2. Assignment 3 is not covered until test number 2. So you do not have to worry about propositional logic appearing on the first test. The practice exercises for inferences and semantic relations, set theory, and relations and functions are due on Sunday. So, so everything that's covered on test 1, the assignments have been, sorry, um, yeah, practice exercises are due Sunday. So the practice exercises for the test 1 content are due Sunday. Most people have finished those by now, but if you haven't, please do them. You don't have to pass them by Sunday, but you do have to have them attempted by Sunday. You can always make an appointment to go over them anytime after that. Can you redo the practice exercises on Monday for revision? Um, I don't know if I can. I think I can give you more attempts on them. I think that's something I can do. If you pass them, I don't see why that's not a problem. I just have to do that manually. So if you do want them, um, if you do want extra attempts, just leave a comment on the practice exercise that you want extra attempts for, and I can give them to you because I do have to do it manually. I can't just do it for everyone at once because Canvas doesn't allow really convenient things to happen for some reason. I don't understand Canvas sometimes. These are like really obvious features that everyone would really want and need, but they don't have them. Yeah. So the time frame and extra time we get. So you can start at any time between 9 a.m. and 9 p.m. You have 60 minutes when you start it to submit it. Canvas auto submits after 60 minutes, but if you don't get your stuff in that 60 minutes, you can email it to me up to 45 minutes late to tblock at sfu.ca, and there's no penalty. So if you start it at 10 a.m., you can submit it on Canvas by 11, or you can email it to me by 11:45 a.m., and there's no penalty. You can just get your work in, and I'll mark it. You don't have to explain yourself, just submit it. So if you have like short technical difficulties, or if you have troubles taking a photo, or troubles uploading work, or internet's a little bit slow, or you need time to check over your work, or whatever, you can email that to me late. If you need extra time to work on things, like for example, you think it's better to take an extra 2 hours to make sure you get everything right than to submit something really quickly and take a risk of getting like 60%, then you can take an extra 2 hours, but you'll be capped at a maximum score of, say, 80%. So I'll still mark it the same way as everyone else if you take really long compared to everyone else, but I'll basically just reduce your score to the maximum on the time limits here. So I don't think like uh, the questions here are not more difficult than the assignments. Well, I shouldn't say they're not more difficult. I should say they're not that much more difficult than the assignments if they are. I'm not intending for them to be more difficult. I'm intending for them to be the same difficulty. However, because it's a timed environment and um, because it's a timed environment and because it's worth 10% of your grade and because you have to work by yourself, they're probably going to seem more difficult, but in the same environment as an assignment, they would be the same difficulty. So my intention is that they're the same difficulty. That's why you have this extra 45 minutes, just in case I misjudge things and in case you have technical difficulties. And if things are too difficult, if I make a mistake there, I will take a look at everyone's grades at the end and I will make adjustments for that because sometimes I do make mistakes. But I've done this a couple times. I know what my expectations are. I know how things usually go. Um, so I'm fairly certain that the test that you are going to receive here is is good. But there's always a chance. There's always a chance. So if things don't go well, do not worry. Do not worry. I I know how things should be. So I will make sure that how things should be and how things are aligned. Like I said, in this course, the assignments are the things that should be the hardest. But please still study, please still learn the material. It's still supposed to be a test of your knowledge. It's not supposed to be a walk in the park. It's still supposed to be a test of your knowledge. Okay, that's all I have for today. So if you have any questions, you can stick around. Um, but yeah, good luck. And I have office hours Monday, 3 to 4, if you need any last minute help. And there's always assignments, email, discussion board, however you need to reach me. Enjoy your weekend.
Thank you.